Hi, in this video we will introduce indefinite integrals. Well, everything starts with the definition of an antiderivative. Recall that capital F is an antiderivative of lowercase f if the derivative of antiderivative is equal to lowercase f. Well, this was a notion that, unlike other notions, we haven't chosen any notation for. We always write, this is antiderivative of f, and always repeat this word, the antiderivative. But after fundamental theorem of calculus, we notice that antiderivative is very important. And, well, since it is in the fundamental theorem of calculus, you remember that if you're integrating a function dx, fundamental theorem of calculus says that just find an antiderivative of that guy and go from a to b of that person. This gives us a good hint that what would be nice notation for antiderivative. You see, when you have limits up there, this works like that. If I drop the limits, then we will have this thing. Well, what about we take this as the notation of antiderivative? And since it doesn't have limits, we have to name it something. That's where indefinite integral comes in. So definition. Indefinite integral of f is denoted by integral of f of x dx without any limits, any numbers in the limits, and it is a notation for antiderivative of f. So by that I mean that integral of indefinite integral of f of x dx is going to be a function f of x if and only if f prime of x is equal to fx. Nothing new, just one notation we are introducing. We are using integral without limits. That's where we call it indefinite integral, and by that we mean our old friend antiderivative of the integrand. Well, let's see some examples. Okay, find antiderivative, well, find indefinite integral. Okay, so here, well, I forgot the x here. Okay, so by this I mean I have to find antiderivative of this guy, but antiderivative of this is can be found if I first simplify. So I separate the limits, the denominator. So it will be x for the first one. For the second one will be x, 2x to the power negative half. For the third one, it will be negative 3x to the power negative 2. And now I know that I can find antiderivative of each one and do the work. So add them, subtract them. So it will be negative 2 times 2x to the power half And then for the last one, this is negative 3 minus x to the power negative 1. Since we are considering all the antiderivative, we always put plus c back there. Well, maybe I do this piece again. So remember the x to the power n. This is going to 1 over negative half plus 1. X to the power negative half plus 1. And this is 1 over 2. 1 over 1 over 2 is 2. Oh, and I have plus 2 here. That's nice. And how about this one? Well, when I look at this, I can write this as 1 over sine squared theta plus sine squared theta over sine squared theta, d theta. And this is cosecant squared theta plus 1 d theta. And I'm finding antiderivative of this, which is nothing but minus cotan squared theta plus antiderivative of 1 is theta. I'm differentiating with respect to anti-differentiating with respect to theta, and we should not forget that plus c. And the last one, well, this is antiderivative of sine inverse of x plus c. Oh, sine inverse of t plus c. The same variable appears there. Well, with this new notation, then the table of anti-differentiation can be turned into the table of indefinite integrals. Well, you can find a complete list of this table in your book, and also properties of indefinite integrals are the ones we had for antiderivative. So if I want to write it, if I have c times fx dx, so constant multiple rule, this will come out the sum of will be integral of f of x dx plus integral of gx dx. And well, for the difference also the same thing comes out. Basically, we can rewrite all the things we learned for antiderivative now in this new notation, indefinite integrals. Okay, so this is the new notation, as I said, and we already know all other things about this antiderivative, which now we can write it in the form of indefinite integral.